Hi everyone, and welcome to One Less Problem. Today I'm going to show you how to solve a system of equations with graphing. So to understand what a system of equations is, or what that means, all it means is you have more than one equation that you have to solve. Introducing this, we're just going to have equations that have only two variables. And throughout this video, we're going to refer to those unknown variables as x and y, because those are probably the most common. That should be familiar to you because we have looked at the equations of lines, and this should ring familiar to you. Y equals mx plus b. That is the slope-intercept form. We also call it y equals mx plus b form, but it truly is the slope and the y-intercept. So today I'm going to show you how do we find out what x and y equal when we are given at least two variables. There are three ways that you can solve a system of equations. And today I'm going to show you what I think is the easiest one because you already have this skill set. What I want you to keep in mind is there are other ways to solve these problems, and usually when you learn the first way and you get it, you don't want to learn the other two. But there are pros and cons to why solving a system with graphing is very helpful and easy. And I want to go over that because in class, when we show students the other two or three ways, they usually tend to stick with one they like the most, and they don't want to do the other ones. But solving a system with graphing does have quite a few cons, and that's why I want to go over them with you today so that you know the best way to solve a system of equations. So let's take a look at our two problems. We do have two unknown variables, and you're usually used to solving equations with only one missing variable, let alone adding another one into it that has to satisfy the equation. So our first step in these problems is getting the y alone. That's why I have isolate y up there. The reason we do this is because I mentioned this equation of line that you're familiar with. In slope-intercept form, the y is by itself. So if I take a look at this first equation that I have here, y equals 2x, you have to ask yourself, is the y isolated? In this case, yes, y is to the left of the equal sign, so it's already isolated. But you might ask yourself, well, I see a 2x, but I don't have a y-intercept. So do you remember what we have to put there? I feel like I'm like Dora the Explorer. Like, do you know what we have to put there? Well, we don't have a y-intercept, so we know that we can say plus 0. That means there's nothing there. Let's take a look at the second one. We have x plus y equals 3. This is an equation, and you have to ask yourself, is the y by itself? Is it isolated? No, unfortunately it's not. So we do have to do a little bit of moving around of the variables so that we get it into the form that we want. So it's easy for us to graph. So if I need to get this x by itself, the y by itself, I have to move this x. So we have a positive x here, so I'm going to do the opposite operation and subtract x to this side, and what I do on one side I have to do to the other. This cancels out, and I'm left with y equals, I'm just going to rearrange this, a negative x, and this is a positive 3, or a plus 3. Now I'm going to ask you one more thing. If we do not have a coefficient, meaning a number in front of a variable, there is something that's there. Do you remember what it is? I'm doing that Dora thing again. It's not a 0, but it's a 1. So in this case, this means that there is a negative 1x. So now at this point, I have my two equations that I'm going to graph. The first one that we didn't have to do a lot to, and the second one that we had to manipulate and move around. So look at our next step. Now we're going to graph both of these lines and find the solution. And in order to find the solution, we are going to find where they intersect or where they cross. So let's graph the first one. In y equals 2x plus 0, my y-intercept, meaning where this equation of the line will cross the y-axis, is at 0. So I want you to put a plot at the origin, in this case, on the y-axis. It's going to be at 0, 0. Then let's take a look at the slope. I have 2 as my slope, or my m. Remember, we like our slopes to be in fraction form because it helps us do the rise over run part. So if this is just a 2, we really know it's equal to 2 over 1. So I want you to go to the point that we put at 0, 0, 0, and that means we're going to go up 2 over 1. Make another plot on the graph for yourself. Go up 2 over 1 from that point until you're comfortable with creating the line. That's our first equation that we graphed. Now let's do the other one that we manipulated around. We have y equals negative 1x plus 3. So our starting point from this line is the 3. That is going to be our y-intercept. So find your y-axis, and we're going to go to a positive 3. Put your first plot there. Then my slope is a negative 1. So like I just mentioned, we like this as a fraction. Remember, it's going to be negative 1 over 1. Or I guess we could flip the negatives, but let's just keep the negative 1 on top for right now. So that means at the point that I just put at 0, 3, I'm going to go down 1, because it's a negative 1, to the right 1. Now from that point, I'm going to do it one more time. Down 1 to the right 1. Down 1 to the right 1. Make as many plots as you want so that you have a straight line. Connect the line. Now take a look. This part is our intersection. This is where the two lines meet. So what coordinate point is this at? Well, we can look at it and we can say that the coordinate point is at 1, 2. So let's see if this makes sense. If I go back to my original, if I say that x is 1, I can plug it in. 1 times 2 is 2. Is my y equal to 2? It is. Let's see if it works for the second one. If I plug in if I plug in my answer of 1 and I say negative 1 times 1 is negative 1, and I add 3, is my y equal to 2? It is. Negative 1 plus 3 is a positive 2. So my answer for this one is the coordinate point 1, 2. We can write our answer like a coordinate point, or we could just say x equals 1, y equals 2, and that's okay. Either way, you're right. You found the solution to both of the equations that are there. I do want you to remember that there are some special types of solutions. So in this case, we have one solution. We have a 1 and a 2. We solve for the only numbers that can satisfy the x and y in that equation. So if you think back, when we were first learning to graph lines, we realized that when slopes, or the m, were the same, the lines were parallel. So when we have two lines that are parallel, let's say we were to graph our lines and they're parallel. These lines will never, ever, ever run into each other. Therefore, that would be no solution. So if you're doing these types of problems and you have two slopes that are the same, you graph it, you realize that they're parallel, there is no solution. It's like a tragic math love story. These two lines are never going to meet. There's no solution. There's no intersection. They're going to go on forever and ever and ever and never cross paths. The other one that you need to keep in mind of is, let's say you were isolating the y and you realize both of the lines that you have are exactly the same. When that happens, if you were to graph the same line, you would graph one over the other, and that means that every single point on that line would satisfy both equations. So that's when we say something has infinitely many solutions. And infinitely many solutions means you have the same exact line. This part, where they never meet, is when it is no solution. So this is pretty simple because you already have the skill set of graphing lines. Get the y by itself, graph it, where they cross is the answer. I want to write down some pros and cons of when you would use this versus the other two methods that you're going to learn as well. So the first pro is if you're somebody who just isn't about algebra, this is very little algebra. If you know how to graph a line and you know how to manipulate variables in an equation, you're good. It's pretty easy. Another pro to this is it's relatively fast. If you're given two equations and it's already in y equals mx plus b form, you could do this in probably less than 15 seconds. So it's one of the faster ways when you have y already isolated. Let's talk about the cons. Sometimes you get an equation and the equations don't have whole numbers. And that's okay. Sometimes there are tricks that you can make them whole numbers if you have decimals or fractions. It's still very doable, but we're not going to go into that today. Just know that sometimes you have to do a little bit more work. Another con is sometimes the intersection is not an exact point or an integer number for the coordinate points. In this case, you can't really look at a graph and say, oh, that looks about 1.5. You can't do that. It might be 1 1/3, it might be 1.28. So if it doesn't cross at an exact part on the grid of your graph paper, then you can't say that you know the answer precisely. Which brings me to my next point. You always need graph paper for these. Sometimes you can sketch things out really quickly, but if you do that, it might not be to scale, it might be off, and just like this, you don't have an exact point. So you do need graph paper for these. You do need whole integerial numbers, or you do sometimes even need a ruler. And when you're using big numbers, this would not be the most efficient way. So a lot of students think, oh, this is the easiest way. And it is when you have these things in your favor. So we're going to explore the other two methods to solving systems of equations in a later video with substitution and the elimination method. So stay tuned. I hope you liked this video. I hope it helped you out a little bit. Please subscribe to my channel. I think that's what people say at the end of these. So go ahead and do that. Give it a like. Give it a dislike. I don't know. Is there a dislike button? Do something with it, okay? Thank you very much.